Hi, I'm Will, and welcome back to my series where I use game development as an excuse to talk about systems theory. Last time, I developed a rough outline of Rail Inc., a simulation game I'm building in the vein of the Railroad Tycoon series. A big piece of this work will be analyzing similar games through the lens of systems theory to figure out what does and doesn't work, and why. And to do that, we first need to establish some basic terms for understanding how to break apart systems and learn from them. The term we use for this is system decomposition. For games, we decompose systems by looking for three things: player actions, quantities or states, and relationships between them, usually keeping track of things like whether the relationship is positive or negative, and if it is immediate or takes time to occur. Let's start with what would make a laughably simple system and slowly make it more complex to illustrate how this works. This will be a game system consisting of a single rail route. A player can press a button, add train, that increases the number of trains by 1. This barely qualifies as interactive. The player action is adding a train, the quantity is number of trains, and adding a train increases the number of trains. Easy so far. What's the problem with this system? Players can just hit add train to get as many trains as they want. It doesn't really react or do anything else. How do other train games keep players from instantly having as many trains as they want? Generally, they implement a money system. Buying a train costs money. You can only buy a train if you have enough. This is an example of an immediate negative feedback loop. The loop is immediate because there is no waiting. The cost gets deducted from player funds immediately. The loop provides negative feedback as buying trains decrements money, reducing the player's ability to buy more trains. What's the problem with this system? Players can only buy a certain number of trains, and then they get stuck. There's nothing else to interact with. The system is dead. In other train simulation games, players buy trains to get more money. It doesn't happen immediately, but accumulates as trains make deliveries. So, having more trains immediately increases a player's income rate, and over time, the income rate increases their supply of money. This is a temporal positive feedback loop. The loop is temporal because the player must wait some time before they can buy more trains. The loop is positive because buying more trains eventually allows them to buy even more trains. What have we done? How do these two loops relate to each other? By having an immediate monetary cost and forcing players to wait to see the returns on their investment, we force them to deal with the fact that time exists. This is our first inkling of the idea of pacing. Immediate or short-term negative feedback loops prevent players from immediately winning the game, and player strategies incorporate long-term positive feedback loops to overcome short-term negative feedback loops. Note that this positive feedback loop is unchecked. There is no negative feedback loop that interacts with the same variables. What happens if we add one? First, let's remove this link from number of trains to income, because it's actually a bit more complex. Trains don't magically generate money. Having more trains on a route increases the number of loads in transit at any time, which increases the route's throughput, which is proportional to the income of the route. When you think about it, the first train on a route is the most profitable, and there's diminishing returns as we add more. This can be due to a variety of reasons, but one of them is the traffic on the route. More trains serving a route means more traffic, which reduces the throughput as trains must wait for others to move by, unload at stations, and so on. Eventually, there's so many trains on a route that it experiences deadlock. No trains can move without the danger of colliding, so no trains on the route produce any money. This puts a maximum on the income a player can make from a single route. Eventually, it is no longer worth buying more trains for the route, because either the investment will take too long to be profitable, or it will directly decrease the player's income. Deciding how heavily to penalize traffic is a matter of game balance, a much more complex topic than I'll cover in this video. This new negative feedback loop is how we use the design of the route system to force players to interact with other gameplay systems. Now the player has to make a decision. Do I sink more money into laying track for a new route, or do I continue buying trains for my current routes? In a real game, This system means players have to consider things like route length, sharing track between routes, which trains to upgrade first, among others, because they all impact the level of traffic on routes. But we'll get to those systems later. What lessons can we learn from this for Rail Inc? Balance positive and negative feedback loops to create game pacing. Generally, good player strategies are ones that efficiently use positive feedback loops to overcome negative ones. Adding a resource cost, such as money, to player actions is the most common type of negative feedback loop, but by no means the only one. Consider what elements the negative feedback loops interact with to prevent easy exploits. We'll keep developing these ideas as we analyze games and design Rail Inc. That's it for now. Thanks for watching.